Hey there, class. We're here today. We're going to look at example number 1 from our vectors notes. So in this example, we're going to worry about the concepts behind vector addition and not so much the mathematics that go behind it. So in this particular example, which we will solve again in example number 3 on a more mathematical nature. Here in example 1, we're really just worried about the concepts. And we're going to just do this in what I call graphical methods. So basically just by drawing this out and making measurements. So without further ado, let's go ahead and get started. So when we do the graphical methods, it's all about using a scale. So I have a ruler here off to my side, and basically what I'm going to do here is, you can see this large thing here. I'm going to represent in my scale here, I'm going to use half of this. So basically it's 1, 2, 3, 4 lines. That's going to represent 1 meter. So if I'm going 3 meters, it's going to be 1 meter, 2 meters, and 3 meters. So my first one is 3 meters north. So I'm going to draw that vector in. So I'm going to start down here at the origin. 1, 2, and 3 meters. The vector then is right here. That's my vector end, and of course the vector beginning back here. So this is the vector A. Next, I'm going to draw my 4 meters east. Okay, so again, based on the same scale, we're going to need to draw one 4 meters east here. So here's 1 meter, there's 2 meters, there's 3 meters, and there's 4 meters to the east at this scale. So put my arrow on the end, and it's a displacement, so my displacement vector is like that. Now the displacement, the resultant of these is drawn from the very beginning to the very end. I've used what's called the tip to tail method here, which is where I put the tip of the first to the tail of the second. We can also represent this in a parallelogram method, which might be for a later video. Okay, so the next goal here will be to draw that resultant vector, which is going to be drawn from the very beginning to the very end. And so I'm going to have to kind of move my ruler around here a little bit. Looks like that does a pretty good job of going from the beginning to the end. And we're going to bring up my vector here, and it's going to be drawn from there to, I don't know what that just did. So let me undo that. And let's put our arrow here. So again, this is a vector, so it has an arrow point at the end here, and it's a displacement. So this is our resultant vector when we take and add, looks like the vector A plus the vector B is going to get the resultant. Now, to get the resultant, what we need is we need both a magnitude and we need a direction. As all vectors have, we need that magnitude and direction. So the way I'm going to find the magnitude, again, we're not doing anything really mathematical here. It's just simply to get the idea. So I'm going to make a measurement. I'm noticing here there's 2, there's 4. That looks like about, I'd say it's about 5 meters. So our resultant vector looks like about a 5 meter magnitude, and its direction is going to be the angle. Okay, in this case, this 39 degrees would be measured relative to the east axis. Okay, as we go down here, you notice as I go up here, I'm measuring a larger and larger degree with respect to the east. So I would say that this is 39 degrees to the north of east. Okay, so as a full answer to the question here, doing the graphical methods, I would say my answer is 5 meters at 39 degrees north of east.